Hello everyone, this is Jang Ro from Department of AI Convergence at GIST. This video is part of the homework for the course Intelligent Agent, instructed by Professor Jin-Hyuk Hong. The goal of this homework is to thoroughly explain the concepts of agentic AI and propose a project for building agentic AI apps using AI building tools. My presentation will first clearly define the concept of an AI agent, explain why this technology is so critical right now, and then propose my specific app development project using a framework called Opal. To begin with, we must first define what an agent is and what AI is. According to our course materials, an agent is defined as anything that acts in an environment. It perceives stimuli from its environment and acts upon that environment. Our lectures provide a clear architecture for this. An agent is composed of a body, its sensors and actuators, and a controller, which is the brain, that decides what to do. The body perceives the world and executes actions, while the controller receives percepts from the body and sends commands back to it. So where does AI fit into this? AI, or artificial intelligence, is the capability of computational systems to perform tasks typically associated with human intelligence, such as learning, reasoning, and being flexible. This leads to a critical distinction. AI is the technology we use to build the controller. When an AI serves as a controller for an agent, we get what our course calls an intelligent agent. This distinction is key. A simple agent, like an auto thermostat, has a very simple, non-intelligent controller based on fixed rules. It doesn't learn or adapt. As our course notes state, these are called purely reactive agents. We can categorize intelligent agents based on the type of AI technology powering their controller. If we use a non-data-driven, rule-based symbolic AI approach, we get a symbolic AI-based agent. And if we use a classical data-driven machine learning models, we get an ML-based agent. And if we use a deep neural network, we get a deep learning-based agent. Let's get into more detail. Symbolic AI is the classical top-down approach. It's built on the idea that intelligence can be achieved by giving the machine explicit knowledge and logical rules. This concept covers most of the methodologies we learned before the midterm exam, such as state space searching, CSP, or logic-based expert systems. I'm not going to explain what each method is, since we already covered them in our course. State space searching is the foundation of game-playing AI like the Minimax algorithm, and constraint-satisfying problems are powerful for complex scheduling or layout puzzles. And most famously, rule-based logic powers expert systems. Deep Blue or Watson from IBM is a famous example. The key takeaway here is that the knowledge is symbolic and explicitly programmed by human experts. Machine learning, on the other hand, also known as data-driven approach, is the bottom-up philosophy, and this is what we usually refer to when we say AI nowadays. Instead of giving the AI rules, we give it a data, and it learns implicit patterns. This gives us classical statistical learning models, such as simple probabilistic classifiers or Bayesian networks, which allow an agent to reason intelligently under uncertainty by learning from statistical experience, or reinforcement learning-based agents that learn from trial and error using specific algorithms like Q-learning or SARSA. Deep learning is a form of machine learning, but its use of deep hierarchical neural networks allows it to learn far more complex implicit patterns from massive amounts of data. In the agent world, this first gave us deep reinforcement learning, or deep RL. This is the technology behind DeepMind's AlphaGo and the core of modern autonomous driving systems. These are incredibly powerful agents, but they are typically trained for one specific complex task. The most recent, and for us the most important, breakthrough is LLM-based control, and these LLM-based agents are usually referred to as agentic AI and are actively researched nowadays. The reason why modern agentic AI mostly refers to language models is powerful understanding of our contextual world. communicated through natural language. To be truly agentic, an agent must have autonomy. This means it must be able to handle goals that are not simple and pre-programmed, but are complex, dynamic, and often vague. This is where previous models, even powerful deep reinforcement learning agents like AlphaGo, had limitations. AlphaGo is a superhuman agent, but it is trained for one specific narrow task. You cannot ask it to book your flight or summarize a PDF. This is what makes LLMs the perfect controller for this new wave of agents. LLM's language ability is so great that it seems to have a grasp on underlying principle of reality. Their mastery of language isn't just about chatting, it gives them an emergent grasp on the underlying principles of reality, which unlocks three critical capabilities for autonomy. First, goal decomposition and planning. An LLM can take a complex human language goal like plan a 3-day trip to London and reason about it. It can decompose that goal into a logical plan of smaller, achievable steps. For example, step 1, search for flights, and step 2, find hotels. Step 3, check the weather, and so on. And the second is flexibility and tool use. The LLM's plan isn't rigid. It can flexibly decide it needs more information or needs to perform an action. This is the foundation for tool use. The LLM controller can decide to use a search engine, run a piece of code, or access a database API. And the last thing is generalization. Unlike deep reinforcement learning, the same LLM brain can, in theory, plan a vacation, write codes, and analyze a document. It is a general purpose controller. So the LLM is the first controller technology that provides a scalable way to reason about complex goals and act to achieve them using tools. As the diagram shows, this LLM-based approach creates a ladder of capability. A base LLM by itself, when used in a simple chatbot application, is the most basic implementation. It perceives your last prompt and acts by generating a text response using only its parameterized internal knowledge that sadly cannot be interpreted or verified by human. And we can add an LLM workflow like RAG to give it external knowledge. This makes it a smarter chatbot, one that can, for example, answer questions about specific PDF documents without giving an actual PDF. Final step at the bottom is the REACT framework. That stands for Reason plus Act, and it is the definition of modern agentic AI. It first reasons and plans about the action it would take, and then acts by using external tools through RAG implementations. This works like a loop until the model decides to give a final answer to the user. This Reason and Act framework gave large language models a strong autonomy, allowing them to act as the goal-oriented, flexible controllers we defined earlier as intelligent agents. Building and managing these multiple-step agentic workflows is complex. A workflow builder is the software tool that manages this entire workflow. There are many tools available, such as LangGraph, N8N, Flowise, Diffie, GripTape, and Opal. As you can see on the slide, these tools often specialize. LangGraph, for example, is a library designed to build stateful multi-step applications, which is very suitable for the cyclic React framework. And tools like N8N, on the other hand, is a tool focused on general workflow automation, connecting various APIs to automate processes. This project, the tool I'll be using is Google Opal. Opal is an experimental workflow automation development tool introduced by Google. Its main job is to connect the LLM controller to a body of other tools like file readers or APIs. However, as it is still an experimental phase, it has several key limitations. First, its capabilities are largely restricted to simpler, more linear workflows. It excels at creating chains of actions, but is not designed to easily implement the complex cyclical reason-act loop that a full React agent requires. Second, it relies on external APIs for its LLM controller. This means that LLM fine-tuning is not possible. We must use the base model's out-of-the-box performance. Now, rather than seeing these as just weaknesses, These limitations actually inspired the core features of my project. First, because Opal is not suited for complex reasoning loops, my project will focus on building a robust automation flow, which is what Opal does best. And second, because we cannot fine-tune the LLM, my project will focus on a task where the LLM's raw performance isn't the critical bottleneck. Instead, we will leverage what LLMs naturally do best, their powerful natural language understanding and natural language generation capabilities. Taking these into considerations, my project will be a universal draft generator. We use chatbot services for text generation a lot, and quite a large proportion of those generations are for writing administrative or professional documents. Things like emails, blog posts, or technical report, research proposals, or even presentation scripts like this one I'm currently reading right now. But when we ask a base LLM to write these, the results are often disappointing. Services like ChatGPT or Gemini don't know our personal context. They don't know our writing style, our colleagues, or the history of our projects. The drafts they produce are too generic and rarely match what we actually expected. And to solve this, many new AI apps are being released that use RAG systems. However, most of these RAG services are still limited to specific single-purpose domains. You might have an AI tool that only drafts emails or only writes blog posts, each pulling from its own siloed knowledge. Therefore, my project is to build a general-purpose, context-given draft generator. My agent will be designed to connect to multiple services at once: our KakaoTalk messages, our email history, and our document storage. By referencing the user's past writing style and content across all these sources, the agent can generate a draft for any task that is not only general purpose but also deeply personalized to the user's true context and intent. That's all for my presentation, and thank you for watching.